Good afternoon, physics students. Mr. Fugit here. In this video, we're going to be looking at one of the homework problems from homework number 2 over vectors. Specifically, we're going to be looking at problem number 4, which is the second part of a two-part question. In part 1, we were asked to solve for the horizontal component of a truck's velocity, and in part 2, question number 4, we're going to be solving for the vertical component of the truck's velocity. So just to remind you, the information that we were given from our previous problem statement was this. We were told we were traveling at a 9-degree angle, so we'll represent that here, at a speed or velocity, which we'll represent with a v, of 15 meters per second. Now in our previous problem we introduced a convention, and I said that my horizontal component I was going to represent in blue, and we called that our velocity in the x direction. And our vertical component, I'm going to represent with red, just so we have a good way to keep track of what we're talking about. Now in this problem specifically, we're going to be looking for this vertical component over here. We were also told that we were traveling at an angle of 9 degrees. Now again, what you see on the screen is not specifically 9 degrees, but really it's an exaggerated way of us showing our picture. So in our previous problem, we found the x component. And if you want more explanation there, you can go to that video. Here, we're specifically going to be looking at our y component. Now, as I mentioned in the previous video, don't allow these units, this meters per second, to throw us off. I know in class we haven't done much discussion with velocity or speed, but here we're going to treat it just like we would any other vector. So, let's look at what we have. We're given our angle, theta. We're given our overall velocity, or what we would call our hypotenuse. And then we're looking for our y component, okay, the vertical component of our velocity. So I have theta, my opposite side, and my hypotenuse, which probably means I'm going to use the sine function. So let's see what we can come up with. I know that the sine function, sine of my angle, 9 degrees, should also be equal to my opposite side, which is our velocity in the y direction, divided by my hypotenuse, 15. Now, if I want to get this value by itself, I need to get rid of that 15. So here's what I'm going to do. I'm going to multiply by 15 on both sides of my equation. In doing so, that should cancel out my value of 15 on the right side, and ideally move it over to the left, away from the v sub y, which is what we're looking for. So, to get a better picture of what's going on, once I multiply by 15, that value will get erased, just like this. And what I'll be left with is an expression that looks like this. My velocity in the y direction, let me clean that up just momentarily. My velocity in the y direction should be equal to 15 sine of 9 degrees. So, making sure that I'm in degree mode, I'll plug this into my calculator. 15 sine 9 degrees. And when I do, I should get a value that looks a little bit like this. My velocity in the y direction, remember it is a vector, so don't forget our notation, should be 2.35 if I round to 3 significant figures, meters per second. Now again, don't allow the units to throw you off too much. We're just going to treat this as any other vector. We'll talk about the units as we move forward. But in general, that is how I would go through and solve for the y component of my velocity, using the angle that I was given, as well as the hypotenuse, okay, to solve for my y component. Now, you'll also notice that in the previous video, you solved for the x component. So another way to go about this would be to use my x component and my overall hypotenuse, as well as the Pythagorean theorem to solve for the y component. That is an appropriate way to go about solving this problem, and if you utilize that, you should still get a similar value of 2.35. Best of luck, and let me know if you all have any questions.